Hello everybody. Last time we saw how a microprocessor work and what is the different kinds of bus architecture and other things. Okay, so today we are going to see specifically about 8085 chip, which is a kind of microprocessor which was released a long time ago. It is a 16-bit, it is a 8-bit data kind of thing and a 16-bit processor. Okay, so it has got about 8 address bit, 8 data bit, the both put together it's an address multiplex, and it's got totally around 16 bits for usage. Okay, so that is the kind of thing which we want to see right now. So let's check in some of the things. It's basic architecture. You have to see what are the basic architecture. So we are going to look into those things right now. Okay, so we go here. Okay. Okay, let's see what are the area architecture pin. Okay, so we're here today. We're going to check out all the interfacing with the architecture of 8085 processor. Okay, what does the processor do? Processor is going to process a certain set of signals. Okay, you have a set of signals and you want to process the signals and take a input signal and process it and give it an output signal. That is called a processor. Okay, so signal processing is the basic thing of any kind of processor. Okay, so addition, subtraction, all these things come under the same kind of things, and that is also it's a kind of processing going on. Okay, so that is also a signal. Signals are stored in a certain memory and then used, and calculations are done like addition, subtraction, multiplication, division. Those are also a kind of signals which are manipulated to do addition, subtractions, and other things. Okay, how do you add signals? How do you subtract signals? So today we're going to see the pin diagrams. Okay, what are the pin diagrams of 8085? Now to run something you need what is called a channel or a current or electricity or a clock. Okay, so the first thing you need a current or a clock. So that is given by these two. Okay, this x1 and x2 right here is what which gives you the clock. Okay, clock for the processor. Okay, so it has got two channels in which the clock comes in, and one is half of that and other things. So if you go, it is giving two clocks. Okay, now when the first processor comes up, it sends out a reset signal to the clock is there, but you have to reset all the elements within the processor. So reset in will come in as the first signal. Okay, reset in will come for as the first signal to any of the things, and reset out is the one which goes to different kind of elements which is attached to the microprocessor. Okay, reset out. So first pin is reset out, which is the signal that is given out to all the peripherals. Peripherals is the things which are connected to the microprocessor. Okay, and that is called a reset out. Okay, so clock in is what the clock which has got inside the microprocessor to run a clock. Okay, so it has to run the clock to do all the processing and other things. So that is what is the clock in. Okay, reset out is the thing which goes out to all the peripherals and resets the whole thing and then brings it back to normal position. Okay, that is great. That is why it's called a reset in or reset out. Okay, now if you see here, there is a reset out in here. So the reset in is when you get the signal reset in, then all the things which are inside is cleared, and kind of so that is called a trap signal. Okay, trap signal or a VC signal or other things where the processor is completely stopped. Okay, so that is called a trap signal, which is going to hold acknowledge or it's a kind of other kinds of states which are there. Okay. Now we go into the other second one. One is serial output data and serial input data. When you have what is the serial output data, what is serial? The signals which are sent over as a cycle kind of thing is called a serial output data. When you want to send some serial output signals through a line, then you use serial output data. And when you want to have serial input data, then that is what is the pin 4 and 5 are used for. Okay. Now if we go to the next set of signals, there are other set of signals. These are the set of signals which give you what is called a or interrupt. Okay, interrupt kind of thing, interrupt kind of signals. What are the interrupt kind of signals? Trap, reset 7.5, reset 6.5, 5.5, INTR, INTRA. These are all called what are called the interrupt signals. Interrupt signals are the signals which are sent just to interrupt something and get the acknowledgement back. Those are the kinds of things which are for the external devices. If we want to do is reset and want to get the return back and say what is the thing which is going on and those kind of things. These are the reset signals. Because reset signals are usually sent to all the registers, all the peripheral devices, all the other things which are connected like memory device, IO device and other things. Everything is done through reset signal. First they send it, the microprocessor when it first comes up, it sends all the reset signals to the different elements and then only starts its cycle. Okay. So most of the time these reset things are not used. Okay, why? Because the processor already reset and it's running. So the trap, RST 6.1, RST 5.1, INTR, INTRA are all not used mostly. Only when there is an interrupt they are used. Okay, that too at the beginning when the microprocessor starts operation. And the INTRA, INTRR is the one which is actually the software kind of interrupts that is used. Okay, that is for specific purposes. Specific purposes when it goes out of state, a carry state, and you want to reset a particular element alone. Those kind of interrupts is INTR and INTRA. The AD is the one which has all the address and the data. Okay, so AD 0 to 7 is the AD, address and data multiplex kind of signals. Okay, those kind of signals which has two-way path. One, it can go in, signal can go out, and also signal can come in. That is why it is called an AD. Okay, address and data can go in and come out and those kind of things. Now if you look the other side, only A. Okay, A signal is there, which means that only address is given to the particular device. Okay, which kind of address? Up to 16-bit address is there, and 16-bit address, one is used for address and data multiplex kind of things which are sent out. The other are for taking inside the data or taking out or giving out the data. Okay, so the last 8 bits are the address bit is multiplex, and that is what is used for input output transfer of data from the address bus. Okay, from the address bus, if you want to do any kind of data transfer, you have to use only A0, AD0, AZ1 and AC7. Okay, this is the where actual parallel transfers of data take place. Okay, but from the last to this thing and other things, calculations are done inside. Once you want to transfer that calculation to outside to a memory or a controller or anything, then you have to use the address and the data up to 7. Okay, now this is the address side. Address side is where it just gives out the address, but it never receives anything on these things. Okay, it never receives from A8 to A15. It will not receive anything. Only it can send signal through that bus, and it cannot receive any signals from the bus. Okay, so that is why it is going out. Okay, now S0. Now we come into control signals. Okay, so now we saw data which can be bidirectional, which can come into the processor and go out of the processor up to 8 bytes simultaneously. And then we saw the other kinds of input which was serial, which was SOD and SID. Okay, these are the two things where data can come in and go out. Okay, these are the four totally 8 plus 2, 10 pins where data can come in and go out. Other things, data don't come in and go out. They are all output, either output or input. That's all. Okay, So other things are all just signals. So data means A0 to A7 and S, SOD, okay, SOD, SID, and what else is data? SOD, SID, and those are the only things which are data related. Okay, all others are all control signals, control and other kinds of things. Okay, so the signals that you saw are clock. Then you have reset signals, which are kind of interrupts kind of things, and reset out or reset in, and INTR, INTRA, which are interrupts from the peripherals onto this is a software kind of interrupts which is given by the DMA controller or any other kind of peripheral devices or IO devices to just interrupt the thing, I am ready or something like that. Okay. Now we have come into hold and HLDA. What is hold and HLDA? It's if you want to do a direct memory transfer, what is a DMA? Because DMA is a kind of thing where say you can transfer only up to 8 bits, okay, inside the microprocessor, and then take it out of the microprocessor and things like that. Okay, and if you want to do a huge memory transfer, you cannot do within the 8 thing. You have to get it into the microprocessor and then transfer from the microprocessor to a temporary location, and from the location you have to transfer it to the next memory location. So this cycle is very hard. So for that, if you want to do directly from memory to memory, those kinds from peripherals to memory or memory to peripherals, those kind of direct access, if you just want to give away the bus access control, then you do what is called a DMA. Okay, that DMA is what gives the signal of hold signal HLDS. So DMA, when it is hold, when it's hold signal, then actually the peripheral is doing some kind of work which is doing a transfer, direct transfer of memory from one or memory or an IO from one device to another device, or one device to a memory device, or memory to memory. Those kind of things is hold and HLDA acknowledged. Okay, now we clock out. Clock out is like peripheral devices. They have to have a clock to run on which frequency. Clock means frequency actually. So it's the kind of what frequency is called, what is the voltage level and other things. That is why it is called a clock out. So the microprocessor gives that particular kind of clock to other things, and the clock can be varied within the other controllers and other things, or like IO device and other things. The clock can vary depending on what kind of input output that is coming in. But this is the signal that is given in. This is the actual working signal that is given in. So this is about 5 volts, and what kind of the controls the clock signal is given here. Okay, reset in and ready. Okay, reset in, as I told you already, you can just send a reset out to all the peripheral devices, and you can get a reset in to set the reset the processor to a certain thing, to a predefined value. That is what is called the reset in. Okay, when the first initial thing you do is you put a button on the reset in, and you press the button. Immediately the first signal that enters into the microprocessor is a 36. Okay, pin 36 is where the actual reset in comes in, and from there only the microprocessor takes over and then processing. Okay. So once you want to give up the bus, then you say hold. Okay, you send a HLDA. Okay, you say first thing the device is interrupt to the microprocessor and tells that I want to hold the DMA. So for that it gives you an input called hold. That interrupt signal is called a hold signal, and once the hold signal comes in, then HLDA signal is sent to just to say that okay, you can take over the address bus and you can use the address of the memory by yourself, and then use it and then give me the control back. Once HLDA is given, then you can get the interrupt on the ready signal. Okay, a ready signal is given wherever when something like once a peripheral is ready, it gives you the ready signal. Okay, that is what it comes out as the ready signal. Okay, IO and memory is like input output or memory, which kind of things. So you can send the you can have the processor doing data transfer or anything in only two modes. One is an interrupt input output mode, or it can have a memory mode. So memory mode means DMA and other things can be used, or a register can be used, or a latch can be used. That is called a memory mode. Okay, IO mode is basically for other kinds of things like an interrupt mode kind of thing, and if you want to do a serial transfer and all the things, you can use IO mode. Okay, S1 and S0 or the status kind of thing registers. Okay, now what is the basic control signals that are there? Basic control signals are read, write. S0 is a status signal. Okay, read, write, and what else is there? IOMEM. Okay, IOMEM, and interrupt request or interrupt acknowledgement. These are the five signals. Okay, interrupt request, interrupt acknowledgement, then you have IOMEM, then read write. Read write. So totally five signals are the one which are actually used for control as a kind of control structure for the control. It's called the control bus. Okay. S1 and S0 are the status. Status is like for machine cycles. What is a machine cycle? Machine cycle is like if you want to have an opcode and you want to decode the opcode, and then that opcode, what kind of state that opcode is, then that is what is S1 and S0 is. So that is a state of in what state the microprocessor is operating. Okay, that is the state which is given. Okay, S0, S1 is where the signals are. Okay, 00 means it is just in interrupt mode, or 01 means it is in register mode. 0 11 means trap mode. So about 8 to 12 different about 8 different signals are there within the thing, but S1 and S0 are the prominent ones, and IOM is the other one which is connected thing. So we have seen the pin inside. Okay, now we go back. This is the basic thing which we want to see first before you enter into the kind of thing which we are going to do. So now we have, that is for outside. What are the pins we saw? That was outside. That pins is right here. So I have clubbed all the things right here. Okay. So how to construct these things? That is why I am teaching you all the things. How to construct this, how to prepare an address bus, how to design a microcontroller, how to design a microprocessor, those kind of things. So what are the output pins and input pins that I have put in here, right here. So this is the complete pinout structures of microprocessor. So let's check in what is there inside. Okay, so it's got a clock out signal, it has got a ready signal, it's got a read signal, write signal, ALE, address enable. So control is read, write, address latch enable, IOMEM, hold, address latch enable, hold, and DMA. Oh no, what is the interrupt request and interrupt request and interrupt acknowledgement. So those are the five signals which are control signals. Status signals is like S0 and S1. S0, S1 is what kind of machine cycle it is going on. That is why it is called a status signal. Okay, machine cycle can be fetch, read, write, or something like that. So those kind of DMA kind of read, write, or something like that. So that is why it is called a status. Okay, that is a status kind of signal or a signal bus. Okay, it has got a bus. So control bus, let's see, let's go in and check how it looks like inside. Okay, so it is all, so you have a clock out which has got like a tap, and you can tap into it and then use it as a kind of signal to put it outside. So it is pointing outside, which means that it is good. Ready signal is going inside. Our read, write, address latch enable, those kinds of things are right there. Status is given out with the signal which is given out, which is, that is why it's called a status. IOMEM is an input or output both, so it has got a bi-directional thing, but I have just given it a single direction. Later we will see how it works as a bi-directional thing, because if I use a triode, you can control it either way, so you don't have to worry about those things. Whole signal is like this, LDA, hold acknowledgement, reset in, reset out. Okay, that's all. So this is the bus architecture, bus of our 8085 processor. So I've given all the signals collected here, and I've classified those things into clock out, ready, control, status, and DMA, and interrupt, and reset in, reset out, interrupt kind of things. Uh, so once you have done registers, but first thing is register selection. So let's go into what are the things which are inside. Okay, from this set of things, we separate out what is called a control bus. Okay, CS is a control bus kind of things. Okay, now there is an address bus which goes inside. Okay, inside the processor you got about address bus about 16 8-bit address kind of thing which goes on inside the processor. So the data, the flip-flops that are used here are about 16 flip-flops are used here, which are doing for DMA and other things. Okay. Another one is 8085 timer. Okay, this is the basic thing of a timer. Okay, so you got a timer which goes inside here, and you have an accumulator and a temporary register. These two are clubbed together. Let's see how it looks like inside. Okay, now this is how an accumulator and a temporary register looks like inside. So yeah, I put it as a kind of chip inside, so it is easier for you to look at the things how it. So bus comes in, it's a data bus. So about 8 pins are there, 8 data bus pins are there, and here also this is the inside of a data in. Okay, of the first 8 bits, and this is data in for the second 8 data bits, and this is the kind of 8 data bits outside out, and this is another kind of 8 bit data out. Okay, control is how many controls are there for this thing. Just about for a register you have about how many controls are there. Read 0, read 1. Okay, this is about 16 pin register, so it has got a read 0, read 1, and it has got a clock, it has got a reset, and it has got a clear. Okay, then it does a minor thing what is called a exchange. Okay, that's all. Okay, so you have a clock, you have a read 0, read 1, and write 0, write 1. Okay, write 0, write 1, clock I've already told you, and a reset 0, reset 1. Okay, clear 0, clear 1. Okay, these are the basic signals of a register, so that you have to understand very clearly. That is what I have given here. GPR signals, what are the signals which are given here. Okay, so I put all the data. Okay, data input pins, so 8 data input, 16 data, another 8 data input, and 8 data output, and another 8 data output. So the read signal, the write signal, and so I put all these things together to make an accumulator. Accumulator always works with temporary register, so I put 16 pins onto the accumulator so that we can work simultaneously. Okay, then you have the arithmetic logic unit, that also has about 16 pins. Okay, because you have to take it from the arithmetic logic. If you want to do add two things, you need 16 bits. So 8 bit is from accumulator, and 8 bit is from temporary register. That is fed on to the arithmetic and logic unit. Okay, arithmetic and logic register. From that arithmetic logic register, it goes to the arithmetic logic buffer. It's a kind of buffer. Okay, arithmetic and the logic unit. Okay, it goes into the arithmetic and logic unit. Now this is a machine cycle generator, so I put in all the other registers right here. So if you see all the other registers, 1, 2, 3, 4, 5, 6, 7. Okay, we got about 7 registers, all 16 bit, and each one is separated as WZ, register BC, resistor D. So totally 60, and this is the mux. Okay, this is the mux for the all the 16, 16, 32. This is the mux. Mux is needed basically for internal transfer, internal bus transfer. The internal buses, if you want to do any kind of internal transfer or external transfer, you use a mux. Okay, the mux structure is somewhat like this. Okay, let's see how a mux looks like inside. It's got nothing but, kind of, we saw the WZ register. We'll see a mux, what is there inside a mux. So it has got a set of pins, about 8 pins are there. Okay, 8 pins. It has a input and an output. That's all. It's a kind of bus, kind of the tri-state device. This is a mux. Okay, you connect the two mux. You connect the two mux and do the connection work, and you get a register. Okay, that is the bus, how it is connected. Okay, the register bus is connected like this, and you can use the external pins as a kind of output pin, so you can use them as a kind of bus. Okay, so we've used this, all this 32 16 16 32 bits as bus, and you can access any one of those bus structures. Okay, now this is the 8255 timer. This is the machine cycle encoder. Okay, let's go out and see how a machine cycle looks like and things like that. We'll see. Okay, this is the instruction decoder. Okay, this has got all the pins inside, and it's got all the signals coming in, and it's got what are the pinouts that is given. I have not made any connections right now. Connections can be made as independently depending on what kind of opcode and address that is. So it will generate all the machine cycle instruction decoder. So that is the machine cycle decoder, and what will be the machine cycle inside, we'll see. Machine cycle inside will be actually the timer that is coming in, a set of timers to run all the control circuitry. Okay, set of timers to run all the control circuitry. That is what address bus, data bus, and other things. Code. It has got machine code buffer. Then it's got an instruction cycle buffer. Okay, so machine code buffer was where the code comes in and stays there, and then after that it is encoded into timing signals, and the corresponding timing signal is turned on. Let's go out and see how it is done. Timing and control. So it has got a status register and a control register. Now for register A there is a timer, register B there is a timer, C there is a timer, D there is a timer, E there is a H timer. This is for low bytes on A, B, C, D, H. Okay, for higher bytes of this thing will be used for the other timer, the second timer. Okay, A, B, C, D as high timer is used for the other kinds of stuff. Okay, so any one of this timer is set to toggle the data. The data is right here, and from the data it reads out what is the machine code, and from the machine code it comes into the data registry. From the data registry it goes into the machine cycle. This is where the machine cycle starts. Okay, machine cycle has got all the timers kind of things and the data set in for that. So if you want to do a move instruction cycle, it is first you have to load. Move instruction cycle is from one register to another register, so it takes about 2 cycles. That is why you are given 2T. Okay, 2 timers. Okay, so it just if you want a move cycle, then it's got to, that is a move immediate kind of instruction. Say if you want to do a load kind of instructions and then move. Okay, then if it's a dual kind of thing, so for that you have to have 4 cycles. Okay, so you need 4 timers, 4 time clocks. Okay, it will do a tick tock of 4 pulses, and then you can do a complete transfer from one data unit to another data unit. So 2 pulses or 4 pulses or DMA. Okay, or sometimes 3 pulses can be used. 3 pulses mostly they don't use, so they use mostly for T4 timers or 2 timers or DMA kind of thing. That's all. So if you want to do an internal transfer from A to B, B to A, those timers are used here, okay? So that is why we have these things here. So if you want to do a registry transfer from A to B, okay, you set in the timer A and you set in the timer B, and then you give a clock immediately from move A to move B happens, okay? So from A to B, the data gets transferred. Say you would give a right signal of A to B, then the timer, the clock is given down there, and then immediately it's just a right signal. That's called the machine code cycle, okay? DEHLLM. Okay, these are the kinds of HLM that is coming. So you can do an internal transfer from C to D, D to C, and if it is M, then it gives the control outside to the read-write unit or the other kinds of things that come in. Okay, so it's a memory instruction means it goes out. Okay, it goes out to a DMA. Okay, if it is memory instruction, it goes out to DMA and creates an interrupt, and then interrupts the memory and gives the memory control to the DMA straight away. So the DMA has to interrupt to clear this timer. Okay, that's all. So load instructions, move instructions, arithmetic add, data manipulation, logical operations, control and branch group, IO interrupt, okay, stack machine counter. Okay, how do these things match up? Okay, once you have, I told you one is it has got an opcode and machine cycle. So the machine cycle used to decode the thing. The first is, if it is the first bit is 0, then it is an arithmetic add subtract, okay, or sort of multiply. The second bit is, if it is 0, then you have data manipulation group. Okay, second bit is 1 means data manipulation, like 7C. Okay, like FF means F means it has got all 1 bit, so the first 2 things are used. Okay, so it just depends on what kind of bit it is set in, those kind of opcode, the machine code is generated. So logical or control branch group, IO interrupt group, stack machine group. If you want to go look up the instruction set, you can look up the instruction set and what kind of machine code will be encoded here for the timer. Okay. We'll see how a mux control looks like. This we have seen already. Okay, reset in, reset out, hold, and other 6 data bits must. Microcontroller, parallel write. See, if we want to do a parallel write on some of the things, you can have a bus type like this, and you can use it to do a parallel read write channel select. You can do a channel select and do a parallel read write. So 88-way timing and control. So you've seen all the basic pinouts and microprocessor, how it is designed. What is an architecture? Architecture set of kind of design to make something work. Okay, so the way you want that, it's called an architecture. Okay, that's all for today. Let's see some other things. So today we saw how a microprocessor works, what are the different registers, how it is built, what are different data elements, how they built, what is the bus structure, and how we use this bus structure to control the elements. Okay, so signal control. That's all for today.